That's a, another way to look at this particular what lookup is what. So there is a base data, then there is a source data, and we perform comparison. If it matches, then get lookup value, LKP value, lookup value from lookup table. That's it. This is another way to look at it, which means for a given key, we can obtain the corresponding value, or for a given name, or for a given code, we can get corresponding value. For example, country code, example, let's say IND. Then you will have India in this particular lookup table. So from the source, you will have, let's say, from the source, you will have IND. Then we compare the lookup, LKP, then get corresponding country name, which is what India. This simple example, to understand like how the lookup works, which means for a given key, get the corresponding value from the lookup. Yeah. So this one way to look at how lookup works. Yeah. But the problem with this lookup is that so we need to make sure that we have got enough memory which can fit all the rows of lookup data. Yeah. So if not, it's better to go with what? Either join or with any other combinable way, like write a SQL query or take care of coding Java, Python, whatever, right? Another way we need to take a look at. Yeah. Because lookup is it expects entire data to be part of the memory so that some source you can compare. Yeah. Or we can also have lookup data which can be stored in the cache. Yeah. So we've got different types of caches. I'll talk about it, but yes. So complete data. So source data will come with a cache, then performs what? Lookup. That's with respect to cache. If first priority is what? Have enough memory, better to go with this. If not, at least maintain with a cache. If not, then we need to go with what? Other combinable transformations. Yeah. That's a theory. That's simple concept, right? Now within this lookup, we got two subcategories or two types of lookups. One is what? Connected lookup. Another is what? Unconnected lookup. Yeah. Connected lookup. Yeah. And another one is what? Unconnected lookup. Yeah. So connected lookup. So this will happen with what? Pipelining. Yeah. I repeat, connected lookup. It happens with what? Pipelining. This is what? No pipelining. Yeah. So that's it. Yeah. So pipelining means so data transfer happens through pipe. Example, we talked about here only, right? So we can see line with arrow indicates what? Through which data flow happens. Yeah. So why we use a pipe? See, we got different IPC mechanisms, right? Any operating system, inter-process communication. Within that, we got different types of IPC mechanism, like a pipe, or we have FIFO, and we have message queues, and we have shared memory, and we got TCP/IP sockets. Yes or no? So we got different types of IPC mechanisms. One of the IPC mechanisms that will be used by Informatica is what? Pipe, through which data flow would take place. That is why is pipe running. So it's simple way to understand from normal terms, which is what? It is a line with arrow. Yeah. So which means through which data flow would take place. It's as simple as that. So wherever in case the lookup is connected with a line with arrow, meaning it's a connected lookup. It's a simple way to understand. Yeah. And another one, which is what unconnected lookup, which is going to be what no pipelining, meaning we don't use pipe. So no connection, meaning you will have lookup like this, which is just like an orphan or zombie or simple reusable block where we configure the lookup and then source data will be connected to some other transformation, example expression, where we can make a call to the lookup, which is so let's say lookup. Yeah. So then once you make a call, right, then you'll get a return value. Return value like whatever lookup is going to return. So that will be transferred to a target. So this is another way to perform the lookup. See, for large, this is better. For low to mid volume, this is better. So because there's a data transfer right here, chunk would take place here. Just like it happens through callee and caller. In this case of callee and caller, scholar, who is a caller here? This guy. And caller is this guy. That's it. So which means just like a simple function block, where in one function, example, let's say lookup, where it takes, let us say, some department number as input. Yeah. Then, so within this lookup, we are going to what I call perform the return. Return what department name, example, right? So D name. Yeah. So that's it. So here, your it is going to return as a string here. Oh, what I'm doing here. That's it. So now this is how we define lookup. Then someone has to call, right? That's a main method. Yeah. So main method will be from let's say we have what lookup by passing department number. So what happens? So this part we configure as part of what expression transformation. This is expression transformation. This is a lookup. So here we are making a call. Control comes over here and returns what corresponding department name. That's all it happens. Yeah, that's a reality within the code. Yeah, but outside we'll just configure. Yeah? So that's a concept. Now let us try to do it practically. Yeah. Any questions on this concept? It's very straightforward, but I'm just asking if you have any questions. Venkat and so Shravanti. Okay. Now let us try to perform this. I think you can hear me, right, Venkat and Shravanti? Because I didn't ask.
Yes, I can hear you.
Okay, fine.
Yeah, I can.
Okay, thank you. So now let us start. Yeah. Yeah, let's configure this. We'll use source as a SEQ1 and lookup as SEQ2. Yes. Now we need to configure lookup. Yeah, because name conflict. This part I think we know it. Just give some name. Yeah. Now we can build a condition. See, column from source with the column with the lookup. See, C1 is a lookup. Here is source is C1. That's all. And comparison can use any comparison operator. So let's say we are using equality operator. Yeah. Now return fields. By default, all the fields is going to return in case of connected lookup. But in case of unconnected, it can return only one. But logically, right? So we expect only one. For a given key, get the value. That's main goal of lookup. Yeah. Yes. Now let's configure target. Okay. Now let us apply the target file, which is let's say lookup, which is a connected based on C1, get the C2, right? So based on C1, yeah, and get let's say C2. Yes, that's all. Yes. Now we got all the 9 rows got processed, right? So remember, lookup is not mandated that, so there has to be a match. If there is no match, right, lookup data will be empty. Let us see that. See here, first three there is a match. So we can see all the return values from the lookup C1, C2, C3. They are the lookup columns, right? And then this one, see, there is no match. And what happens? Lookup values will be empty. That's all. Then these guys got matched. So we can see lookup data. And last two, there is no match. There is no data from the lookup, which means this is equal to left outer join from the join transformation. That's it. Because left outer join means, I think as we discussed earlier, so we don't miss any data from the left table, but the right table data will be empty, null, or zero. So that's what you can see. Yeah. So that's a lookup. Now lookup connected. Now let us try getting into unconnected lookup. Yeah. Yeah. Now let's configure the lookup independently. Maximize. First step. Can you see? We need to enable the checkbox, which indicates unconnected, which means we cannot connect this to other transformations or target or source, whatever. Yeah. Next, incoming field will be one because anybody can call this particular lookup. Example, I'll just put here lookup input. Input could be sometimes department number, whatever. Then based on that input, we configure the lookup. Yeah. Which means whoever is going to call, right, that lookup input, that they have to pass as input to this. Just like last stored procedure, right, which takes some in parameter, same as this. Then it will return out parameter. So out will see. So let's just execute to here. Say okay. Now we can build a lookup condition. So lookup field, same as earlier. Here, see here, lookup input. So this part should be obtained from what? Caller. And this relational operator is the same as earlier. Yeah. Return value will be only one. Can you see? Last, there is a radio button, right? You can say it. Yeah. Radio button means only one can be selected. Checkbox means multi. Yeah. So you can just observe this for some time. Yes, that's all about lookup. Now let us start from the source. So someone should call this unconnected lookup, right? For that, we can select what the expression transformation. Yeah. Yes. Let's say we can make a call from here. It's not that we need to make a call from here only. So we can also call it from even Java transformation. Yeah. Yeah. So input, let's use same thing, and we expect the same result as we got it from the connector lookup. Yeah. Input, let us say seq1.txt. Yeah. Say okay. Yeah. Now let us call from here. Oh, sorry guys. Actually, there is some power problem from my side. I've just connected with mobile network. So yeah, I was trying to talk about, I don't know where we lost. So I was trying to talk about like how to configure this lookup independently, where we supply the incoming field, example lookup input, then supply this lookup object, which is seq2, next lookup condition, next return. So we are trying to return here C2. That's what we need to do as part of the lookup configuration, right? So I hope all of you could able to see my desktop, right? Yeah. Now let us configure the source like SEQ1, so that we discussed earlier, right? And then expression transformation, where we can make a call to the lookup. That's what we are trying to do now, right? So go to built-in functions, and supply the input here. Yeah. So which is C1 here. Because for a given C1, we expect what? C2, right? Yeah, that's it. And then say, okay. Yeah, now let's configure the target. Yes. Now let's say look up unconnected based on C1, get C2, right? Dot txt. Yeah. So that's it. Yeah. So same. Okay. That's all. Now let us save it and run. Yeah. Okay. Let's monitor this. So let us refresh that. Yeah, that's all. So we should get the same result as connector lookup. See here. So we got the result. Yeah. So first four rows, there's a match. Here also there's a match. Here there is no match. That's why right table data is what? Empty. Here also it's empty. Yeah. So that's it. Only C2 value we are saying it here. Because in case of connected, it will return all the fields. But here only one. Whatever we specify, right? Only that value will be returned here. So that's it. Like how we can configure the lookup. Yeah. Next, see, it is going to make use of different types of caches, which includes like static cache. That's very simple. So, which means we have got different types of caches. Cache is a temporary place which will be used for manipulation or to perform lookup, we use it. Yes or no? So that's where we use what cache. Now static means, let us say we got 30 rows. In run one, I'll take first run, where we need to process 30 rows. Yeah. Then cache would take place for what? 30 rows. Yeah. So that's it. So now next run, second run, let's say we get the same data, 30 rows. Again, here also, recreation of cache. So I'll just put here recreate cache, recreate. Yeah. So recreate cache. Yeah. For 30 rows would take, irrespective of whether there is a match or not. It doesn't look at like what was done earlier. Same process will be repeated for other runs. Let's say run 3. 30 rows only, but out of them 28 rows are similar and 2 rows are dissimilar. In this case also, for all 30 rows, cache will be created. That's it. This way for every time, right, recreation of cache would take place irrespective of whether there is a match or not. Right now, the question, do we have any way to avoid recreation of cache for the matching records? So that's where we can introduce what another type of cache, which is what? So dynamic cache, where we focus only on what I call either modified data or new data. So we don't create a cache for what process data. For example, first time the cache will be created. This is a run one. Let's repeat the same thing. So run one, cache will be created. Then if you go to run two, then what happens? In the second case, I'm trying to use exactly same data. No recreation of cache. So we are avoiding recreation of cache. Yeah. So next, let's say we go to run three. Yeah. So run three, what happens? Out of 30, 28 rows are similar. Only for 2 rows, recreation would take place. Recreation means what? Update. Yeah. So update would happen for what? Modified data. Yeah. So that's it. Yeah. So that's what happens with respect to what dynamic cache. Yeah. But there are too many changes, right? Static is better. Minor changes or no changes, dynamic is better. So, so we need to carry out the data analysis, and based on that, we need to take a call. What would be the right caching type that we can choose? Yeah. So next, we can go with what? Let us say we need to make use of cache in more than one task. Can we use either static or dynamic? Answer is no. Because in both the cases, as and when the scope of lookup got over, they'll be erased. Now, how to make it available for other tasks? Example, let's say we got task one. Yeah. Then we got what task two. Yeah. So so now what happens? Here, let's say cache is created. Example, cache one. Yeah. So then same cache can be used in task two, which is a cache one. Yeah. So which means this type of cache is what I call persistent cache. where we persist the created cache and use it in what? Any other task. That's where persistent cache would come in. Now let us take another case where we got a mapping. Within the mapping itself, there are more than two lookups. Let us take two lookups for now. So in this case, let's say we need to refer the same lookup. Then what happens? Can we use a persistent or some other cache? No. In that case, we use what? Shared cache. Where once you create a cache, right? It will be used in what? N number of lookups in the same mapping. That's it. Like how this particular what you call caching would take place over here. Yes or no? Yeah, that's it. Yeah. How this particular cache works in lookup. Yeah. Now, if you want to configure, so you can just go to lookup and advanced. Yeah. See, lookup cache persistent. Yeah. So whatever cache that you wanted, and this cache size, index cache size, it is same as what we discussed in aggregator and also in joiner. Yeah. And static cache also we can see here. Yeah. So that's it. Yeah. Now another one, sorted input, right? I think we talked about see. So we can also use, let's say, lookup with sorted transformation as input as a lookup. You know, so that lookup happens a bit faster because indexing will take place here also, right? Let's introduce this sorted part here. I think we have done it for aggregator and also joiner, right? Same concept holds good here. So nothing beyond that. Yeah. Yes. Now let's reconfigure this because you'll have some conflict. Yeah. Say okay. So rest everything is same. So lookup object, lookup condition, return fields. Yeah. Everything is same. There's no change. Now let us save and run. Yeah. Yes. We got 9 rows. This one, right? Whatever, doesn't matter. Connected, unconnected, doesn't matter. Yeah. Result will be same. It is sorted, that's it. So you can see ascending order, right? So earlier we have just got in not sorted order. Yeah. So whatever data comes out from the source, so it maintains the same order in the target. But here it maintains it what sorted order. So that's the difference between the with sort, without sort, and with sort. Yeah. So that's it about caching stuff and some optimal options. Yeah. Now let us try getting into what small transformation. Let us see. Yes, we have less time, right? Now let me talk about some lookup itself. Yeah. So lookup, we can talk about it. But I think from the developer perspective, this is enough. Elaborated. Yeah. So remember, guys, see, lookup goal is what mainly just to get some value. That's it. Yeah. So now the question, where do we maintain this particular lookup? That is a question mark. Yeah. So where is it going to be in the file? Is it a best one, or database, or application, or something else like cloud, or distributed cache, or shared cache, or some other storage media, which can be taken as a base to perform the lookup? See, there are many questions, right? Answer is what? So it's better to use what? Tiny database. Yeah. So, like example, we got a solid database, which is very good, which is a tiny, small one, plus the operation bit faster. If you try to use that as a Teradata, which is not advisable to maintain lookup in this kind of very large database, because there are VLDBs, right? Very large databases. Yes, sir. This is not advisable. Like Redshift or this one or Hex or some other large database, which is not recommended here. Yeah. So that's why we need to go with what tiny databases like Solid or MySQL or some other Postgre, whatever. Such kind of database are the good ones to choose what look up. Yeah. Now, when you take some business cases, right? So let's say we have got what manufacturing industry. Let's take this. Yeah. So where let's say people are producing different types of products out of them. Some are keyboard, some are CPU, some are something else. Now the question in this case also we can use what product type. Yeah. So product type is going to be the lookup type, sorry, key, and you'll get what corresponding product name, yeah, which is product name. So this is what we do when it comes to what manufacturing industry. Likewise, you can extend this to pharma industry, yes, any other telecom industry, whatsoever. Yeah. So there are some examples where we can think of using this what lookup. Like I think we talked about department, like any organization, right? Where we got multiple departments. In that case, department will be the department number will be the key and get corresponding department name. That's for normal organizations. So if you take investment banking, also where we have customer type, like a tier one, tier two, tier three customers, and then get corresponding attributes. In that case, also we can have this lookup usage. Yeah, but the limitation with this particular lookup is that yes, we need to make sure that the lookup data can fit in memory. If not, better to go without other combinable transformation where we can fit, where we can go with a larger example, joiner transformation, where we normally don't hit upper limit in case of a disk because temporary operation would take place in a disk as a result. So we don't hit threshold limit. So then for large lookup data, better to go with joiner. For low volume of lookup data, then choose This lookup. That's it. That's a bottom line. Yeah, I think that's enough. So let me cover small topic here. So let us say we need to build or we need to run one particular task. Or can we run the mapping directly? No. Then how do you run it? By creating a task, which is a mapping task, which is equal to session task in Power Center. Let us create it. It's a small topic. I don't know whether I covered or not, but let me cover. So mapping task from a template. So which is a template here? Mapping. Mapping is just it's like a skeleton or a blueprint or a template for constructing number of objects. So this is going to be the object, which is for every mapping. We can create multiple instances. Each instance will act as what? A task. Like in object orientation, we got objects and classes, right? So class equivalent term is mapping here, and object equivalent term task here. That's it, as simple as that. Because we can create multiple tasks based on what mapping. Similarly, in object orientation also, we can create multiple objects based on a class. So that's what we use the term. Instantiation of a class is what I call an object. So we all know that, right? In object orientation. Yeah. So let us take random environment and supply the mapping. So, but here you will have many options to configure scheduling part, parameterization part, and also what performance attributes, and also the way we execute standard mode or verbose mode, or sending notification in case of warning or success or failure. Such kinds of things also we can have it as part of task level. So which can't be done at such particular mapping level. See, schedule, email notification, parameterization, execution mode, and ELT optimization, advanced session properties, where we can configure n number of properties like buffer size or partitions, all that. Like we configure session of what we call properties as part of Power Center, right? Same concept holds good here also. Yeah. So let's say that. So I think with this, let's say we covered all the combinable transformations. Tomorrow we will talk about other transformations. Yeah. So this week we'll try to check. And probably need more time, then we can probably will spend like long hours, like 2 hours like that, so that we can just get it finished. And I request all of you to practice and come up with questions. So I'll answer any kind of question. Mostly I'll answer it, not all. But even if I don't know, also I'll definitely try to get the answer. Yeah. But yes, you can ask any kind of question.
Do we have a session log system or in the cloud as well?
Yes. Can you see here? So yes, when you run it, example gives a PhD with the it's now it's completed. Can you see here? Download button. So you can just download it. So this is
Okay.
exactly what. So we call it as a mapping task log, but equal to session. So you got the log, right? So this. Okay. So this is what you are expecting, right? Okay. Here it is exactly equal to session. Right? At the end you can see session logs complete. Yeah. So like source.
Mm-hmm.
And in between, it follows what ETM architecture, like what you follow in Power Center. I think that's what you are referring, right? So,
Yeah.
yeah. So same thing. You can see it. Yeah. Except the difference is we don't need to create a workflow. It itself is going to create what? The temporary workflow, WF underscore whatever. And Even terms also, it uses same thing inside session task. Yeah. With the MTT means mapping task type. And rest is same, no change. Yeah. See, this is just a copied version from Power Center. They have not created a new thing. They have just enabled a cloud, nothing else. Something. Yeah. So
Okay.
whatever can be done in, yes, please.
So now you're saying that, I mean, here we don't require to create any workflow, right?
Yes. If you want, we can
Uh,
create.
that, okay.
Let
Like,
it.
if these
Uh,
are like manually we are running, and there will be a tools, right? Normally in production system, we have a tools for nightly jobs to be run, like
mhm.
say control M jobs for the purpose center. Does this
Right.
also support? Like cloud
Yes.
also is supported? Okay.
Exactly. So it's yeah. Let me just elaborate. See, first thing we can schedule within itself, like what we have seen here itself. Like here I think it's in that. Yeah. Can you see scheduling option? See, control
Yeah.
M or is a Tivoli, right? They're all just third-party scheduling tools. So yes. So we can also schedule it. That's one option. Yeah. Now I'll come to a question. Can we call this particular task from third-party schedulers? Answer is yes. Like for example, Power Center, we create a shell script or bash script by using a pmcmd command. Right? We form a command
Yes.
and put
Mm-hmm.
shell script and get it called from third-party schedulers. Yes or no? Same way,
Yeah.
so we can do it. There is a rdtm command, like similar to pmcmd. Here we got rdtm command using which we can form a script and get it. Yeah,
Okay. Yeah.
anywhere. Yeah.
Thank you.
So I think it's completed. Wait, it is completed. So that's it. Like how to create a task from an existing. Okay. Yeah. So tomorrow, anyway, workflow, similar thing we have it here. Task flows. I'll come to that. But yes, without workflows, it is today. Yeah. So okay. So I will talk about. Let's finish one by one. Let's close all the transformations. Then after that, we'll get into this. What tasks, different types of tasks. Then task flows. Then we'll talk about some debugging and tuning. This is how I plan actually this whole training. Because first we need to get what we have. Second, we need to extend it. Third, we need to optimize it. This is how we need to understand, right? Yes or no? First, we need to make sure that functionality is right. Second, we need to get into what can we extend. And third, we need to get into what if you get stuck with something, how to troubleshoot debugging. Then, is there any way to optimize? So that's where performance tuning. Yeah. So so that's why I normally plan systematic way. So in case if you want different way, I can change it. I don't have any problem to change this. I'm very flexible. Yeah. So here you can see, I think tomorrow we'll talk about expression transformation. I think we have not discussed, right? We can talk about it tomorrow. I think that is, it will take one day anyway. After that, we'll see day after Java transformation and then maplet, then followed by normalizer rank, then followed by sequence SQL. Yeah, that's it. Then, yeah, transaction is a very small thing. Then we'll get into what? Tasks. So like different types of tasks, we'll talk about it. Then task flow, then debugging and tuning. So that's a plan. Yeah. So I hope you have got access to videos, right, everyone? So Savanthi, Ajit, and Venkat. And make sure that you just play them and your questions. Yeah. You can ask any kind of question at any topic. I'll answer that. Yeah. So that's all for today. So we'll continue from it tomorrow. Yeah. So thanks to all and bye.
That's